are you guys ready to learn about x86?
Yes.
Okay. All right. So, okay, I guess I have to hit here.
There,
Yeah. So so these are like basically just the things we're gonna go over today. So like first registers, which are basically the variables of x86. It's a little different, so we're gonna be talking about that and like what are ones you can use, what's different about them. We're gonna talk about ways you can load data, move it around to different registers, move it between registers and RAM or memory or anything like that, as well as your first basic instructions for x86. And we'll have a little bit of sample code for that in action. So first we're going to talk about general registers. So there's 16 registers called the general registers. So you see them right there, the list of 64-bit registers, RAX, RBX, CX, and all that. So you basically, those are what you use to, like, as the variables in your code. So if you ever, like, instead of like declaring an integer x and like setting that to some value, you'd set like, say, register AX to a value. You can't just use any register to like use it for your variable. Some of them have special purposes. So like, for example, RBX, I don't know if you know what a stack is, but it's something very important, and if you change your location on the stack while running a program, very bad things will happen. Same thing with basically most all of those other things. They're very important in your programs, and so if you just like change them around a ton, sometimes bad things will happen. Now that being said, there are lots of other registers you can use that are very, very useful in your code. So good examples of those are the RBX and R10 through 15. So those are the ones you can use like if you want to do any calculations within your actual code. So here they are again, of course. And when you say RAX, basically that says you're referring to the A register, and you want the 64-bit version of it. So these are all referring to the exact same register, except this means you want to use 64 bits of it. This means you only want to use 32 bits. This is 16 bits, and these are both 8-bit versions. So I guess I'm gonna like just draw that out if you want to visualize it. So like this is your entire register. Your register is always going to be 64 bits. So if you were to call like RAX, that would refer to this entire thing. If you only want half of it, you would call EAX. That's the 32-bit version, and then I guess just AX is 16. And then for AH and AL, those are like sub-ones inside of this. Yeah.
So I thought x86 and x64 were different instruction set recognitions.
Wait, so say that again?
I thought that x86 and x86-64 had different instruction set recognitions.
So usually when you talk about x86, you're talking about x86-64. There's also the 32-bit version, but yeah, I mean, and also x86-64 is going to have all those old registers to have backwards compatibility too. Yeah. So these are the registers, you will use them. So data movement. So going back to the example of like integer x is equal to like 5. The equivalent of that in assembly would be like if you were to use, let's say RAX is your x for this case. You'd say RA to MOV, just move, then RAX, and then 5, like after the comma. So that assigns the value 5 to our register RAX. Now, of course, there's different ways that data is stored. One is in the registers, which are like the data inside of your processor. Then there's also memory, and there's immediate values. So immediate value will be like just writing a number, like, so like move RAX 5 would be an example of moving immediate to your register. And you can also reference memory using special things. So like you say move RAX and then you say some address in memory. So then you load something from memory into your register so you can use it in your program. I'm not going to go into too many details about that because it's kind of a lot. You're just in your like introductory things, you won't really need to use all of those features. Just basically registers. Okay, I guess. Okay, so here's an example of that. I don't know if you remember the hello world function we had last time, but basically, here's an example of using that. Here you're assigning the register REX to the value 100 with the move function. And then, I don't know how familiar you guys are with C, but basically, if you wanted to print an integer using printf, you would be like printf and like some text, and then you use $d, and then after a comma, you would put like whatever your number is, and then that would go inside of where the d is. So this here and this here are kind of like the two arguments for your printf function. So we're calling a C function inside of our assembly code. And so this is really the easiest way for us to actually print out stuff for now. Like in case we want to like just test our code and see, make it do something we can actually see. Because like just adding stuff together and not actually having any results is kind of boring. You want to actually have those results happen. Okay, so next, your first arithmetic functions. So add and subtract. So add, you're gonna usually use two registers, like you say RAX and RBX. So if you wrote add RAX, RBX, you take those two together and add them together and store the value in RAX. So like if RAX was equal to 100 and RBX was equal to 50, and you did add RAX, RBX, the new value in RAX would be 150. So I think you might be able to use at least one. You would refer to one memory when you're using add, but they can't both be referred to memory. That's just some details that you might not need for now. And the destination, the one on the left, cannot be an immediate value, which kind of makes sense because the immediate value isn't really referring to a data location, so you can't add a number to something that doesn't really exist anywhere. Yeah.
Can you add another register on the end, so you have like you're adding two registers and storing it in a different register, or do you have to override?
No, you have to override. So yeah. I mean, you could like move the like you store it somewhere else, but yeah, that's how they x86 chooses to do it. Okay, and then here's the example. You set REX and RBX to like some values, and then you add them together into REX, and then you just print it out to get your result. Okay, so multiplication and division are kind of different, and it's like our first example of where specific registers have specific purposes, and you see that importance. So multiplication, you do multiply and then some register, and then what happens is that value is multiplied by the RAX register, and that value is then again stored in the RAX register. So the same thing. It's pretty much the same thing for division, but it also uses the D register when you're doing division. I'm not going to go into the details, but basically when it runs that instruction, it does need to use the D register. So an example of that in action. So you set RDX to 0 because that's an important thing. Then you set RAX to 16, so like that's the one that we're dividing it by. And then we're going to divide it by rbx, which we're going to set to 2. So when you run rbx and divide, you just get rex is 8, of course. So this is just like a basic example of that. And then multiply, you do the same thing, except you wouldn't need to set rbx to 0. Okay, so let me know if I'm going too fast or if you have any questions and I'm not explaining anything enough. Okay, so AND OR and XOR, those are very similar to the add and subtract functions. It's just doing a different operation where you have the destination and source and the answer is placed inside the destination. Of course, like again. Are you guys all familiar with like AND OR and XOR? Okay, so yeah, it just basically does a bitwise logic function and then places that in the destination. They can't both be in memory. Again. And that's basically it. Okay, so I didn't give an example for that because it's so similar to add and subtract. Just like this, just a different operation. Not is a little different. So basically, whatever's an op, it just takes that and just switches all of its bits. That's it. So compare, that's where we start to get in like our control structures. So like basically if we want to have certain code run on certain conditions, this is where the beginning of that all starts. So it just, you'll see why this is important in a second, but you just provide 2 registers that you're going to compare together. Okay. So these are used with compare. So for example, you do compare rex and compare rbx, and then you'd say JE, and then some label. So label is basically a location inside of your code. So if you do compare rex and rbx, and then rex is less than rbx, then you will go to wherever the label is. And that might not make a lot of sense right now, but an example. And also like the JGE. Actually, also I have cheat sheets that have all these instructions. So I'm gonna like pass them out later so you can, because you're not gonna remember all this, of course. Yeah, I'll go to the next thing. Yeah, so here, the print and the end, these are the labels. So you see, we set RX to 100, and you see, so JN is jump if not equal to. So because they're not equal to each other, we will skip this print function completely, and we'll just go to the end. And so, so they're all, that's basically how they work. You can do interesting things with that. So looping, it's also it's pretty similar to the the jumping things, because like that's how you do what you do if you want to do like, for example, a for loop. So it uses RCX, and so like if you wanted to like loop through something 10 times, you'd say set RCX equal to 10, do these operations, and it'll keep going through like a little thing of code until RCX reaches 0, and then that'll be it. And then it eventually will go to the label. And I think I have an example of that too. Okay. So see, the RCX is to 10, so that means you're going to run through that 10 times. Do you guys know what's happening here? What's happening here? Is there, okay. Yeah, take some time, because it's an interesting math thing, and I want you to figure it out. Yes. Yes, Fibonacci. Yeah, so you set the initial values as 1, and you store it in RDX, EA, and then and it does 10 times, so it'll, at the end, it'll print like the 10th Fibonacci number.